Here's an example of a variable situation of work. Suppose a fireman is carrying a hose up a 30-meter ladder. If each meter of the hose has 1.5 kilograms of mass, how much work must he do? Well, let's think about it. The force, if you think about it, here's your force. The force, when the hose is entirely on the ground, he's doing no work. And as he goes up the ladder, the hose gets heavier and heavier and heavier. He has to carry the hose that's in his hand and the hose below it and the hose below it. And as he pulls up, the hose is going to get heavier and heavier. Well, how much heavier? Well, 1.5 kilograms exerts how much force? 1.5 times 9.8, which is 1.5 times 9.8, which is 14.7. 14.7 newtons. So every meter. So this guy is going from 0 up to 30 meters, and the force of the hose is going to be, the force in terms of x is 14.7 x newtons. If that makes sense. So every single meter of that hose weighs 14.7 newtons. And what we want is the area of this. As you can sort of see, the amount of work that this person is doing most of it is right near the end. At first, when he's only a few meters up the ladder, the hose is fairly light. It's not exerting much force on him, it's not too hard. But near the end, as he's dragging it up, I guess you could lean it against the ladder. But he doesn't. No, he's pulling it straight off the ground because that's the kind of fireman this is, a mathematical fireman. So the total work is going to, as we said, the integral from a to b of f of x dx, which in this case is the integral from 0 to 30 of 14.7x dx, and you could have figured it out as a triangle, but the integral is pretty easy too. 14.7x squared over 2, evaluated from 0 to 30. Plugging in 0 doesn't do anything, so it's 14.7 times 30 squared all over 2, which is 30 squared times 14.7 equals, divided by 2 is 6,615 joules of energy.